Thank you very much for coming to the JBC and I'm super happy to see all of you in person again. So today, in the keynote, we're going to talk about how to be a good cloud citizen. And maybe some of you may be thinking, why cloud? Why today we are in the cloud? And of course, there's a lot of reasons for that, but I'm going to say one. Let me show you something. I think that 20% of you know what is this. Right? At least I say that it's senior developers for age, no? But today we've got this. So we've been evolving from this computer to something super more powerful. But there are more things that I would like to show. Do you remember when we were listening music with this? We've got it, all the music here. We need to, take the computer, download the files, put it here. And today, we've got something like this. We've got a Spotify, for example, listening the music in a streaming. So we do not need to download anything. We've evolved from this, with all the devices that we need to carry with us, with just one device. And also, if you just think about more about this, who played with something like this? I know that it's quite more old. This was, I remember playing with my mom. It was two screens. This is how I played when I was young. And today, my daughter plays with this. So everything is evolving, right? We were starting with small machines. Now we've got things that are super powerful. But let's talk about as the developers, because we've got also some evolving. We've gone from waterfall to agile to DevOps. We've gone from the monolith application to entire application to the microservices. Well, I know that here it says microservices. Maybe some of you are doing just services architecture, but nowadays, most of us are doing services architecture. And also, it changes how we are deploying and packaging the applications. I remember when I started working, like it was maybe 24 years ago, I've got the production server under my table. It was there, and I know that it happens. Bad things like, oh, I'm just going to push this button, and the production server has been restarting, and things like that. It happened. Then, we know that this was not the way to work. We moved to virtual servers, and finally, we end up with containers. So I'm not saying that everyone here is just putting his workloads in a container, but probably you're doing it. And also change the application infrastructure. We moved from data centers. We've got the data centers on site. Then it was something like, okay, it's not necessary to have all the data center in my, let's say, in my building. I can just go to another building, just rent some servers. We go from a hosted approach, and now we are in the cloud. In theory, we do not care about the machines. They are just there, running. We just push our code, and everything is running. But there are a lot of different clouds. Maybe you are in, to say some Amazon. Maybe you are in Google. Maybe you are in Azure. There are several different kinds of clouds. There's even an indoor cloud, because there are some companies that are creating their own cloud, their on-prem cloud. This also exists. There are companies that they are not using public clouds. They're using a cloud, but they are running inside its company. And we even know zombie clusters, because how many of you have just let the cluster there up and running for maybe 2 weeks, and they said, oh, I remember this cluster. I needed to shut down, but I didn't do that. So you're creating a zombie cluster, which is there, but it's live, okay, but it's that. But how to start moving to the cloud? Well, the first thing that you need to do is choose your tools wisely, what you are deploying to this cloud. And I would say that one of the options that you've got is Quarkus. Quarkus is Java framework and tooling and so on that lets you create enterprise Java applications that just uses, 16 megabytes of RAM, and it just starts with 16 milliseconds. Of course, the boot up time is not important at all, at least in some cases. In others, like serverless, yeah, it's true that it's important. But if not, yeah, the boot up time is not that important. But what is really important is the memory. Because the less memory your process uses, the more deployment density you got it. And why it's important, deployment density? Because sometimes when you're in the cloud, you are paying for the machines. You're paying for the memory that you need in that machines. So the more memory you want, the more memory you need. More money you need, sorry. So if you've got processes that runs in less memory, it means that you can deploy them in the same machine. Using less memory means that you are saving money. Also, it's really important when you are in the cloud to announce your intentions, because you know that when you are using Kubernetes, if you do not announce your intentions, if you do not put the request memory and the limits memory, the process will start consuming as much memory as possible and as much CPU as possible. So you can deploy a lot of services inside the same node, but if one of these services start consuming memory, it will affect the memory of the other containers, the other services. So it's really, really important if you want to be a good cloud citizen to announce your intentions, putting the request memory and the limit memory. Also, important to tell you when you are ready. Because in Kubernetes, you've got one thing that is named readiness proof. A readiness proof is used to know that the application is ready. Because you need to know that in Kubernetes, from the point of view of Kubernetes, when you start a container, when the container is started, the service is ready. But that's not true, because the container is up and running, but maybe your service is booting up. Maybe it takes 1 minute to boot up. Or maybe it's updating the distributed memory cache. So from the point of view of Kubernetes, you're ready, but the application might not. And this is why we've got the readiness proof, to make known to Kubernetes that the application is up and ready. So if you want to do rolling updates, you want to make rolling updates with 0 downtime, then always set the readiness proof. If not, you might be able to do rolling updates, that's true, but you will get some downtimes. Also, tell the people that you are alive, because we have not only readiness proof, but also liveness proof. Okay? What is a liveness proof? Well, it's a way to detect zombie containers. Containers that are running, but they are not responding. So they are not dead because they are running, but at the same time they are not alive because they are not responding. Why are they not responding? Well, maybe because there is a deadlock in the service. Maybe because it's overloaded, so you've got an overloaded service there that cannot get more connections. So at this point, what Kubernetes will do when a liveness proof fails is to just restart the container. So it's really important also to set the liveness proof. So when there is a deadlock, when there is a problem with the container, Kubernetes can restart it. Also, when you are into the services architecture, you need to be resilient, secure, elastic, share your metrics, and also enable intelligent traffic splitting. Because at the very end, when we are in a service architecture, we've got several services, all of them interconnected, using the network, and the network is a one point of failure. So you need to be resilient, so if the network is down, you do not get a super exception throwing all the services down. Also, you need to be secure. At the end, this is where an attacker could sniff the traffic. You need to be elastic. You should be able to scale up, scale down, so on. You need to share the metrics. You need to enable intelligent traffic. You need to be able to do progressive delivery with your microservices architecture. And this is where another great tool for Kubernetes comes, which is Istio. Istio is a service mesh. And why you should adopt Istio in your Kubernetes cluster? Well, basically for this. In Red Hat, we created this, and it's not an hexagon, it's I don't know how many. Well, this piece of around it, which named microservices, which are some key things that your services should have. You have your service, your business logic there, but around you should have also an API to connect to that service, a way to discover other services, a way to invoke services, scale up, scale down the services for elasticity. If you've got a spike of traffic, you should be able to handle it. You need to be resilient in case of errors. Each of the service needs to be deployable in an isolated way, so alone. You need to authenticate between these services, and you've got the login, monitoring, and tracing of what is known as an observability. So to implement this, you can use several libraries out there, but for discovery, you can use Istio. Because I know that in Kubernetes, you also have discovery. I know that you have the concept of Kubernetes service. But Istio is super more powerful. You've got the invocation and the elasticity with Kubernetes. You know that you can do kubectl scale, and automatically the pods goes up or down. But then, what about the other gaps? Resiliency is covered by Istio. Pipeline can be covered by Tekton, another great technology of Kubernetes. Authentication, how you can authenticate between these services that you've deployed on your cluster. Just use Istio. It does everything automatically. All the certificate authority, all the revoking certificates, updating certificates, everything is done automatically. So all your communications between services are secure. And logging, monitoring, and tracing is something that can be done automatically with Istio as well. And this is an example of the YAML files that you can apply to your Kubernetes cluster if you have Istio installed. In the first one, you see that it's really, really small. And this one, okay? I'm just saying I want to secure with MTLS all the communications of my service. So with just applying this YAML file, which in fact it's applied by default when you install Istio, all the communication within services will be secure without doing anything at all. For you as a developer, will still work with HTTP. So no certificates, no certificate authority problems, no private keys, nothing. And Istio will encrypt for you the communications. In the second example here in the authentication part, I'm just saying that you'll receive a barrier token, and this barrier token needs to be validated. And you can just put all in your services to validate this token, or you can rely on Istio, and Istio will take care of all validating the token that has not been compromised, that it's not expired, validate that has the correct roles, and so on. And the third one, this one, is how to do a canary release with Istio. Because if you have been working with Kubernetes, you know that creating a blue-green deployment, yeah, it's more or less easy. You can play with Kubernetes services and labels. But when you try to do a canary release or a dark launch, well, it's quite harder. And with Istio, you just need to apply this YAML file, and you're done. But it's even more tools that you can choose when you are into the Kubernetes, into the cloud wall. And basically, what's happened when you've got your services, but they are just running from, 8 a.m. until 8 p.m. So during the night, they are just down. They are not receiving any traffic at all. You can just keep them running, so consuming energy, or you could scale down automatically. And this is exactly what Knative does. Knative is the way that you have in Kubernetes to deploy serverless workloads. And it's really powerful, Knative, because it lets you deploy serverless workloads without having any vendor lock-in. It's just a container. So you can move from Amazon to Azure to Google, and it's always the same container running as a serverless workload. And also, if you see this, it's super small YAML file. It's just, I don't know, maybe five lines, 1, 2, 3, 4, 5, 6, 10 lines, okay? You just set the container image, and that's all. Under the covers, Knative and Kubernetes will create the pod, the replica set, the deployment, the Kubernetes service, it will set a URL, and so on. Everything will happen automatically with just this small YAML file. Also, it's really, really important to automate everything, because I think that nobody will think that it's a good practice to SSH, right? Server and copy there your production code. Well, maybe some of you are doing it, but it's really not a good practice. It's better to have everything automated. But what's happened with Kubernetes? How you can automate this? And maybe some of you are saying, oh yeah, I'm doing kubectl apply to the cluster, and I am applying the resources. And that's one way of doing it, of course. But if you were not SSH any virtual server in the past, why are you doing kubectl now? And basically, it's when all these GitOps methodology, this DevOps, where everything is Git, is in Git. Git is the source of truth. This is where everything, all your continuous integration, all your continuous delivery stuff is. And that's a really nice way of working, because thanks to GitOps, you're able to version your continuous integration, your continuous delivery pipeline. It lets you monitor what's going on. It lets you audit why something is in that way. Keep in mind that if you want, for example, to increase the number of pods from 1 to 2, you might do a kubectl scale, which then it's not traceable at all. You do not know why you did that. You know at that moment, but maybe not 1 month after that. If you're using GitOps, you will exactly know why you increased from 1 to 2, because basically you will do a git commit with a comment. And that comment, maybe you might say, yeah, we need another instance for resiliency purposes. So at any time, anyone will be able to go there and say, oh, look, now I know why we moved from 1 to 2, because we want it for resiliency. And that's a really cool way to work. In the part of the continuous integration, well, OK, you can use GitHub Actions, of course. You can use Jenkins. You can use Tekton. In the part of the continuous delivery, I might say that there are like 2 platforms out there that are native to Kubernetes, or the more famous one. In case of we at Red Hat, we think that Argo CD is the really good choice, which let you deploy to Kubernetes in an easy way, with not using kubectl apply, but just listening or monitoring a Git repo. And then in the part of the management of the delivery, we also, in my case, I really like Argo rollouts. Argo rollouts is a tool that lets you automatically do progressive delivery. So if you want to start getting into the GitOps and Kubernetes, I recommend you as well Argo CD and Argo rollouts. This is how Tekton, or a Tekton resource is. This is the CI part. It's really simple. You see that I'm just defining a task, and then I define here some steps. In this case, there is only one step, which basically is a container, because in Tekton, everything is a container. So you're just setting, OK, I want to compile my Java project, just open or start the Maven container, and just run Maven clean install inside that container. See that in this way, your pipeline is always reproducible, and also it's another key point here, and it's that you are building your project inside the cluster or the same cluster that you're going to run in production, which is always a good practice. Because we know that in theory, containers should be portable across all the machines and all the operating systems and so on. But if you've been with containers for a long time, you know that that's not entirely true. There are some corner cases which are not working at all. So it's a really good practice to build your containers in the same machines that they are going to be deployed. And then here we've got the CD part. This is the Argo CD. You see that this is a kind of application which basically say, I want to deploy something in the BGD namespace, and all these YAML files, all the YAML files that I want to apply to this cluster are in this repo. So I'm just going to clone this repo. I mean that Kubernetes is going to automatically clone this repo, monitor this repo for any change, and when it detects the change, it will deploy the changes. Where? Where you've set it here, in this server. And one of the great things about this is that you can start deploying the same application in several Kubernetes clusters, because it's just a matter of changing this server value. So you can start adopting the hybrid cloud thing. You can just have different clouds, maybe the same cloud in different regions, or different clouds, like I've got Amazon and Azure, and I want to have all of them having the same application. So it's just a matter of changing this value, and the application will be deployed there. And now we start with another topic, which is the multi-cloud or the hybrid cloud. How we can make that applications deploy to one cloud and another cloud. So maybe you're putting your application in Amazon, but you also need to put your application in Azure, maybe for latency, because maybe where you want to have this application, there is no Amazon data center, but there is one that is Azure. So you want to deploy your application there and also in the Amazon one. So you need to manage all these applications. You need to make your application behave like one, even though it's deployed in several clouds. And this is exactly what a Scupper does. Scupper is a tool that it's super nice because it works at layer 7. It means that it works at application level. And why it's perfect, this tooling for doing multi-cloud? Because you don't need to take care about things like, firewall rules, complicated level 4 things, doing configurations that as developers we really do not know how they work. With Scupper, it's layer 7 application, just let's say HTTP. And one of the great things of a Scupper is that it connects to all the sites and makes them make just one application. Even though you've got your application deployed in Amazon, your application deployed in Azure, a Scupper will make you, as a developer, feel that it's exactly the same application. And a Scupper will take care of routing the traffic to the correct cloud. You can just, for example, configure a Scupper for routing the traffic for latency. So you can say, just send the traffic to the nearest node. Or you can just have a Scupper as a backup. So you can have all your application in Amazon, then you've got your dormant application in Google, for example, and if the Amazon cloud is down, automatically Scupper will start routing the traffic to Google. So it's a really nice project. It's super easy to use. I mean, that sometimes when I'm talking about this, it's like, whoa, this should be super complicated. And it's not. It's easy to start. And I really recommend you that if you are thinking about using hybrid cloud, just take a look at the Scupper, which I think it's version 1.1 now. So it's pretty mature. It has been used in production as well. So yeah, just take a look. Now, I'm going to show you some demos, because even though it's keynote, I always want, or I always enjoy showing some code. And I've got here my application. I've got two applications. This one is an Istio application, and this one is a Knative application. I've got two applications. The Knative one is really simple because it's just a YAML file, as I said before. Let me show you the example. It's simple. It's just this a small YAML file with this liveness and readiness proof. How you can deploy this application? Okay, you could do a kubectl apply of this, which I'm not going to do it because I said that in production it's better to not do that kind of things. And I'm going to use Argo CD. How I can, oops, it's the Knative application, sorry, it's here. This is how I define it, the application in Argo CD. I'm just setting the cluster that I want to deploy it, the URL where the application is deployed, and you see that in the path I'm setting the folder, which is Knative. In target revision, you set the branch, and then, well, I'm just saying that I want to automatically deploy it when I apply this file. So now I can do kubectl apply -f of this Knative thing. This, you only need to do it once, and now, after that point, every time that there is a change on this repo inside this folder, automatically will take the change and apply it to the cluster. Now the application, it's been deployed. I can go to my cluster, which is here. And let's wait. You see that says no revisions. Well, nothing. Now it's been deployed. OK, finally it's deployed. And it's automatically deployed. I've not done any kubectl apply of this resource. In fact, if I go to the Argo CD dashboard, you see that it has been detected, that for now it's out of sync. It means that it's still deploying. And you can see all the information. You see how all the resources have been created. As I said before, with Knative, I'm just putting this small YAML file, but it creates a bunch of resources. You see the service, the ingress, also just getting the pod scalar, just deploying, has the revision, has the some elements right there. The the pod. Well, these are things, but the namespace, the replica set, and so on. So it just creates all this stuff for you. Now I guess that I've got Kian. No, I have no Kian installed, but doesn't matter because I can go here. This is my service. Come on. I think there is. Well, you see now that it's working. It says, hi, greeter, and it says that it's deployed. I can even Kubernetes. I think it's in the default namespace. You see now that I've got this pod running. This is a Knative pod running. Let's wait. OK, now you see that it's running. Now, what is the great thing about Knative is that after 1 minute of not receiving any traffic, the pod will automatically scale down to 0. When it's scaled down to 0, means that it's not going to use no memory, no CPU, which means that all cloud providers cannot bill for something that we are not using. So thanks to Knative, we can save a lot of money. Let's wait a bit, 1 minute. By default, Knative just scales down after 1 minute, but this is configurable. You can say 5 minutes, 10 minutes, 30 seconds, whatever. OK, now, oops. You see now, the pod is terminating. I've not done anything at all, but Knative detected that, OK, I'm not getting any traffic, so I'm going to scale down. Let's see. Now it says that there is no resources. But what's happened if I just go there and said, OK, but I want to make another request now. When I do the request, you'll see, yeah, I've done the request now. And if I do kubectl get pods, you see that now the pod is up and running again. So it just detects that there is a new request, that detects that there is no pod, so it just boot up. And in the same way, you can just detect spikes of traffic and scale up to more instances. So with Knative, you can configure that you want to scale not to 1, but for example, scale to maybe 5. So it's you say, okay, when I detect a spike of traffic, I want to create another instance, and another instance, and another instance. So it adapts depending on your traffic. So it can scale up, and after 1 minute of no traffic, it starts scaling down. And this happens, as I said, automatically. Now, this Knative. Let me show you another example with Istio. And Istio example is far more complicated. You see that I've got 3 services. One is named customer, another preference, another recommendation. And there is, well, one file that's named customization. Customization is another tool. It's like Helm. Okay, but let's say that I like more customized than Helm, because in most of the cases it works, and it's simpler than Helm. So, well, but you can just, if you want to see this file, it's just this. I'm just setting, this is a customization file in the Nemesis tutorial, and I want you to apply all the resources that I defined in the customer folder, in the preference folder, in the recommendation folder, and Istio files folder, and that's all. That's all the things that I need to set. But again, I don't want to apply this directly to the cluster. I want to use Argo CD. I want to use GitOps approach. And I have, of course, this file, which is exactly the same as before. It's the same repo, but now the folder is Istio instead of Knative. So let's apply this. It takes some time, but come on, Wi-Fi, you can do it. It's just like you've got to apply with a small YAML file. It's not, you know, I'm not sending a movie. Okay, yeah. It's nice because I'm just seeing errors that I've never seen. Thanks to the slow responsive network. Rico's consult. I think that, yeah, I removed it yesterday. Let me check if I removed it yesterday, the example. Maybe it's already there. Okay, I think that I'm going to do another thing. I think that I throw the mobile here. Then I should see my as well now. So where is the problem? Now it's working. Now, finally, yeah. Okay, now, mobile phones fixes everything at the end. So if I refresh, you'll see that I've got the Knative application and also the Istio application, which is progressing. You see that, as I said before, there is a lot of more things because it's a microservices architecture. Well, it's just 3 services, so it's not big at all. But, well, it helps for the purpose that I want to show you. The application has been deployed. I can just move to the namespace where I'm deploying the application, which is tutorial, give, call, get pods. And what I want you to see, first of all, is that I've got customer preference recommendation, and I've got two versions of recommendation v1 and recommendation v2. So it's just having free services, but the recommendation service has two versions deployed. And the other thing that I want you to notice is that now the application, well, or the pods, has not just one container, but two containers. One container is my business service. The second container is the Istio container. Well, in fact, it's the Envoy proxy container that implements all the microservices that I showed you before. So remember when I said that this is the discovery it can cover with Istio, there is also the authentication and authorization part in Istio. All this stuff is implemented inside this sidecar container. OK, now the application is up and running. Let me get the route, which is here. You see that I'm just calling customer preference recommendation v1, and I do a curl, I'm getting customer preference recommendation v2. Now, what I can do is move the traffic from v1 to v2, and I just need to do the apply virtual service. Remember that I showed you before, and I can send all the traffic to v1 with just applying this YAML file that I showed you before. All the time goes to v1. If I apply, and that's all the last thing, if I apply to v2, I'm just applying a YAML file, and automatically the application or Istio is routing the traffic from v1 to v2 with just applying this YAML file. And that's all. Thank you very much. Hope that you enjoy so much the conference, and see you around. Thank you.